Grande watershed region, a little bit of New Mexico, Texas, and Mexico. So to get started with task 1, which is the overall framework and regional scale, we looked at the site analysis a little bit of the Rio Grande watershed. And for reference, it's this blue region, whoops, and then the state of Texas. Here for context, this is the site boundaries we looked at. We then mapped the protected land within the Rio Grande watershed within Texas, New Mexico, and Colorado a little bit. And so you can see there's a lack of protected land within Texas borders for habitat or land preservation. And then we looked at the extent of mapped Orioles in the USA. This wasn't a GIS file, but it was a scientific article. So I just traced that data and put it here. It was only in the US, so we don't have the Mexico side of the Orioles mapped, but I think they're more extensive in Mexico within the mountainous region. And then for the second to last layer, we looked at the transportation networks, and there's a strong concentration near El Paso for interstates and roads, paved roads. And then lastly, we looked at the free trade zone density. So there's greater density in the south region of Texas and then the El Paso region. So we really wanted to focus on this Big Bend and Ojinaga region to bring eyes and commerce to the full border. And then all of those programs are implemented into our overall framework. So we have some proposed free trade zones in Ojinaga near Big Bend, and then in our evacuation proposed site of Fort Stockton. We're proposing to retrofit the existing interstates and divided highways, which are these black line work shown, and then for green infrastructure to protect migratory species and preserve our natural resources. We're going to expand the Big Bend National Park region, which is this stippled shading, and then also propose a secondary migration crossing for species migrating from Central America and South America. And then for blue infrastructure to mitigate flooding, there's not a lot of flooding, we'll get into that later, but we're implementing Orioles remediation to infiltrate some polluted runoff and dam break runoff that would occur in this region. So for the performance analysis of our design program, we'll get into it in more detail within the other two tasks, but for the first phase for resiliency, where we're implementing a lot of our Orioles and transportation changes, we retrofit about 7.8% of the existing roads in the Rio Grande watershed, and we're managing about 2,500 miles of Orioles, which I guess I should have pointed at the big one over here, my bad. And then phase 2 in 2050 decarbonization, we're focusing on our green energy production with algae biofuel, which will also help us to produce water in this arid region. And we're also focusing on geomagnetic beacons and the migratory crossings shown here along the Pecos River to help with species migrations. And we're implementing about a 12.5 increase of habitat preservation. And so for the third phase, connectivity, where we're trying to protect from solar flares and polar reversal with extraterrestrial habitats and interplanetary transportation, we're retrofitting about 6.9% of more of the existing transportation network, so we can get people efficiently, so we can move people efficiently and safely to our evacuation hub in Fort Stockton. And we're also managing about 6.09% of the floodwaters in our arroyos to help decrease the inundation that would happen, so we can get more people out before they would be flooded. So this is our toolkit that we're implementing. This is an example of the Arroyos diagram. So it's a dry creek bed for most of the year, but in flooding events, they would fill up. And on the Mexico side especially, the Arroyos are used for transportation. So like people will drive on them like a dirt road since they're not flooded most of the year. We have our woven train intersection for migration crossings overhead, and closer to the city, we will have the elevated slower maglev trains. We're also retrofitting the interstates, as we talked about, our geomagnetic pulses, our algae biofuel to reduce water and green energy, and then our extraterrestrial biodomes to protect from solar flares, and then our space launch pads. So here's another diagram for Arroyos. This is an example of how it would look like on the Mexico side of so we would have steeped plantings to help infiltrate and reduce the pollution in runoff. And then we'd also have gabions built with locally sourced materials that would help slow the runoff and let it percolate into the aquifer instead of flooding further downstream. And all of our arroyos would be able to hold about 3,200 acre feet of water. And so getting further into this, for the dam breaks, of all the water that would be broken during the dams, our arroyos would be able to account for 4% of mitigation of that water. All the dam breaks would also be affecting about 10 million people in the Rio Grande watershed region. And so by implementing our arroyos, we'd be able to get that vulnerable population down to about 4 million. For sea level rise, not much of the Rio Grande watershed is affected by inundation. It's about 0.75% of the acreage, and so that's about another 3/4 of the population, especially in Reynosa and Matamoros. And so with our arroyos implemented, we could get that down to about 0.25% flooded of the whole watershed, and then 1/4 of the population still vulnerable. And for polar reversal, it's a larger region flooded, but it's of Texas, but it's still only 2 3/4% of the Rio Grande region. And that would be about 3.25 million people in this region. And so by implementing our arroyos, we'd be able to get that down to 2% inundated still and 2 million people affected.